Welcome to Spring LIB.
31.66. So here on the left, we have what for this problem we are told to imagine is the output from an audio amplifier, which in this case has a high impedance, and that the load capital R over here is a loudspeaker. So in order to maximally transfer energy to our loudspeaker, the impedances should be matched. And clearly 1000 ohms is not 10 ohms. So we're going to use a transformer to get us out of this pickle. First, we want to sketch what this circuit looks like with the transformer. So we can just directly edit the figure here. So you'll have a primary with some number of turns and a secondary. So this is what this is going to look like. And now we want to find for part B, so this is part A basically. For part B, we want the turns ratio we need. Now, there are at least two ways of doing this. One would be to write down what the power in the resistor is as a function of, say, the current over here, and then treat the turns ratio as a real variable, take the derivative of that power, and then maximize it. And that's a really tedious way of doing it. What we can think of instead is, in this situation, we're basically using the transformer to make this sort of situation happen where we have a little r equal to R and a big R equal to little r. So we know that this will maximize the power sent to this resistor. This is like the internal resistance of this battery in this case. But if they're equal and they have the same current going through them, then that means that each one is also dissipating the same amount of power. So what we can do instead is use that condition, and we get the same answer easier at the cost of just a little bit of insight into what the actual behavior of the system is. And I say cost, but that's sort of the whole point of learning these things. So the power that's being dissipated in our big R is going to be the secondary current squared times R. Now the current in the secondary is equal to the turns ratio times the current in the primary. So this means that the power in our speaker is N1 over N2 times the primary current squared times R. And then the power dissipated by the internal resistance of the output of our amplifier will be I1 squared R. And so we know that the maximum amount of power is being transferred to the speaker when these two powers are equal. So we have I1 squared little r is going to be equal to I1 squared times the turn ratio squared times big R. These cancel out, and so we see that the turns ratio we require is equal to the square root of little r over big R. So we're told that little r is 1,000 ohms, and big R is 10 ohms. So 1,000 divided by 10 is 100, and you take the square root of that, and you get that the turns ratio needs to be 10.